Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on Python. And in this video, we will create pair plots. All right. So what is pair plot? It is a very useful plot that shows the relationship between all the parameters in only one plot. All right. So it is very interesting. We can plot all parameters in only one plot. And to do this, we will use Seaborn as our library. And we will start using the previous file. So as you can see, this is our previous file. And you can watch the discussion, the explanation of this code in previous videos. All right. And as you can see, in this code, we use pandas, matplotlib, and Seaborn. Right. This is important. Seaborn. We will generate the pair plot using Seaborn. Okay. So regarding the pair plot, as opposed to plotting scatter plots individually, a pair plot can be used to plot all variables against one another with only one line of code. Okay, I will show you later. So we have mounted the drive by doing this code. Okay, from google.colab import drive, we connect the Google Drive so that it can take the data, the file, in this case, the Excel file, and then use the data, the table in this data, and we will use that for our analysis. Okay, and then this is the path, the pathway to the drive, to the file actually, this one, the name of the file, well underscore flow rates, Excel. Okay, and this is the data frame. I call it df, and this is the table. Okay, this is the table. This is the headers of the columns of the table. Okay, and then this is the distribution plot. This is the join plot in scatter type, KDE type, and then hexagonal type. Right, so this is the pair plot that has been generated, but I will delete it first. Okay, and we will start from a new one. Add one line of code. Okay, to generate the pair plot, it is very easy. We will use Seaborn SNS. Okay, this is the name abbreviation of our Seaborn library. Pair plot. The function is this one, pair plot. Okay, parenthesis. The first one is the name of the data frame, and I call it df, comma, and the second one is the type of the plot. In this case, I want to use scatter plot. So kind equals this one, scatter. All right, we are ready to generate the pair plots. Click run. And we will wait for a while. Okay, so there is a problem. Why? Because there is a typo here. Pair plot. Okay, so let's do it again. Pair plot. Okay, so you can see the syntax, pair plot. The first one is the data frame. Okay, and then if you can use hue, then you can use this one, but I will skip it and I will type in the type of the pair plot after the data frame. Okay, let's do this. Parenthesis. The first one is the data. You can see data. My data frame is called df. Okay, and then the second one is type. Okay, type is scatter plot. All right, we are ready to generate the pair plots. Click. This is not type, actually it is a typo. This should be kind. All right, so that's normal in the coding, and we should wait for a while because it's, yeah, you can see it's a big data, right? And we will generate many plots. You can see later on. Okay, already 17 seconds. We have several parameters and we will plot them against one another. So it will be, yeah, so we will have many plots like this one, right? So very, very interesting. Easy, right? And of course, you cannot do this in Excel, okay? So first I will guide you. The first plot is oil flow rate. Okay, so you can see the flow rate, the data that we have for oil flow rate. You can focus on the diagonal first. This is the water flow rate. Okay, gas flow rate, wellhead pressure, bottom hole pressure, separator pressure, choke opening. Right, so that's for the diagonal. And then this one, for example, water flow rate plotted against the horizontal axis is this one, oil flow rate. Okay, so we can see a general trend. As the oil flow rate increases, water flow rate also increases. Okay, that's normal because they flow simultaneously. And that's also the case for gas flow rate against the oil flow rate. Okay, they flow simultaneously. So as the oil flow increases, of course, the gas flow rate also increases. And this one, wellhead pressure against the oil flow rate. So we can see a negative trend, negative slope. So yeah, that's quite understandable. If we have high wellhead pressure, the flow rate will be choked. Okay, there will be high back pressure, so the oil flow rate will be decreased. But as we decrease the wellhead pressure, we decrease the back pressure, and the flow rate will increase. So that's easy. The same thing with the bottom hole pressure. Okay, and we can see, for example, the relationship between wellhead pressure and the bottom hole pressure. For example, this is the row for wellhead pressure. Now we will find the column for the bottom hole pressure. This one, this is the column for the bottom hole pressure. So we go up to find the wellhead pressure. Okay, this one. This is the plot of wellhead pressure plotted against the bottom hole pressure. Okay, so it is easily understandable. Wellhead pressure increases, bottom hole pressure also increases. Okay, and the other thing, for example, this one. What is it? Gas flow rate against wellhead pressure. Okay, gas flow rate against wellhead pressure. Oh, this is quite interesting. This shows positive trend. So it means that as we increase the wellhead pressure, gas flow rate tends to increase. Okay, wellhead pressure goes to the right, gas flow rate increases. Okay, so in this case, we will check the well condition, the reservoir condition. Okay, and what about this one? Gas flow rate against the bottom hole pressure. And this one is also interesting. Negative trend. As the bottom hole pressure increases, the gas flow rate decreases. Okay, as an engineer, we will find the reason behind that. Okay, is it normal? Is it abnormal? We should check the well condition and the reservoir condition, of course. And also, what about the wellhead pressure and the choke opening? Usually, as we decrease the choke opening, the wellhead pressure will be increased. So let's check. This is the row for wellhead pressure. This is the column for choke opening. So we can, yeah, we can see a negative trend. So as we increase the choke opening, the pressure will be released and the wellhead pressure will decrease. Okay, but if we close the choke opening, we reduce the choke opening, there will be pressure accumulation, there will be back pressure, and of course the wellhead pressure will increase. Okay, so you can do your exercise, you can do your analysis using this plot, this pair plot, which is very interesting and very important. All right, so I think that's all. I hope you enjoy the video. I hope the video is useful. Thank you so much for watching and see you again in the next Python videos. Thank you.